Now we're going to finish up this section with a few exercises that are really important and draw together a lot of what we've been discussing in this chapter. Just note at the top a little commercial. We are skipping something called Descartes' rule of signs. It's really not that important. It is in the textbook though, so you may wonder why it's highlighted in the textbook, but we're just skipping that material totally. No problem with that. So let's move on to this exercise 6 that has different parts to it. They're really separate problems. We're just using the same instructions over and over again. So in each case, construct a polynomial having real coefficients of least possible degree using the given information. So in part A, we want to describe a polynomial having negative 3 as a zero of multiplicity 1, 1 as a zero of multiplicity 2, and we want f of 0 to be equal to 2. So we're putting together a polynomial function. We're deciding what it's going to look like. And the fact that we have information about zeros, we're going to turn that into information about factors, because it's the factors that are part of the expression of the function. So when we say we have negative 3 as a zero of multiplicity 1, that means x minus a negative 3 or x plus 3 is a factor. So we got a factor of x plus 3. And when we say 1 is a zero of multiplicity 2, that means x minus 1 is a factor. Multiplicity 2 means we have to write that factor down twice. So we actually have 3 factors now. X plus 3, x minus 1, x minus 1. And then we're given some additional information about the y-intercept, really, because that's when you plug in 0 for x. Now, from what I have right now, if I plug in 0 for x, I'll get 0 plus 3, or 3, times 0 minus 1. I'll get 3 times negative 1 times negative 1, which is just 3. So as is, this function doesn't work yet, because it doesn't satisfy the f of 0 equals 2 condition. Now we don't want to add additional factors. What we can do here is we can add a scaling factor. Without changing the 0 information. So we can multiply by some constant. We have to find the value of a that works for this function f. And the way I'm going to do that is, what's going to help me figure out what a is this f of 0 equals 2 information. So I'm just going to recopy the function here down below, but I'm going to plug in 0. So I'm going to say f of 0 is a times 0 plus 3 times 0 minus 1 times 0 minus 1. So I just use this expression here. I replace the x's with zeros. Now that condition says that f of 0 should equal 2. So I want 2 to equal a times 3 times negative 1 times negative 1. Well, that means negative 1 times negative 1 is 1, times 3 is 3. So 2 is equal to 3a. Divide both sides by 3. 2/3 is a. And so f of x is equal to 2/3 times x plus 3 times x minus 1, x minus 1. This is the factored form of the polynomial. And if the directions don't say otherwise, I think it's perfectly okay to stop here. But we can also multiply this out. And so when you do homework problems, if you check the answer in the back of the book, you might see the multiplied out form. So you want to make sure you know how to do this if you have to. And so let's go ahead. I'm going to do the multiplied out form. I'm going to leave the 2/3 to last. The x plus 3 I'm going to leave for now. I can only multiply two factors at a time, so I'm going to do x squared minus x minus 2x plus 1. Leaving the 2/3. Now I'm going to multiply the x plus 3 times x squared minus 2x plus 1. So I'll take x here times each term of the second factor. So what am I going to get? I'm going to get x cubed minus 2x squared plus x. Then I'm going to take 3 times each term of the second factor. So plus 3x squared minus 6x plus 3. And combine like terms. So I have x to the 3rd minus 2x squared plus 3x squared is plus x squared. And then I have x minus 6x minus 5x plus 3. And then finally, I'm just going to distribute that 2/3 through to see what the actual coefficients of my polynomial are. So my final answer has lead coefficient 2/3. It's 2/3 x cubed plus 2/3 x squared, distributing the 2/3, minus 2/3 times 5 is 10/3 x. And then finally, plus 2/3 times 3 is 6/3, or 2 wholes. So that's just the multiplied out form. Multiplied out form. So only do that if the directions say multiply it out. And I might ask you to do that on a test or quiz. I might say multiply it out. Answer must be multiplied out. Then it's like this. If you're not told how to write the answer, either one of these would be okay. Okay, so we're done, but I want to say a little bit more. So we're done. Just want to make sure you understand that. This is not part of the problem now. We answered the question. I just want to look at the graph of f. And like, how much can we say about this graph based on what we know about these zeros? We know we have a 0 at 1 and -3. I guess I'm going to draw a new coordinate axis because I drew my y-axis too far. All right. So here's 1. Think of that, -3. We know what the y-intercept is. 2. F of 0 is 2. So we know we have x-intercepts at 1 and at -3. We know the end behavior is like x cubed. So this end of the graph kind of goes off like that. In less than -3, the graph goes plunging down to -infinity. And what do we know about the zeros? X plus 3 has multiplicity 1, so the graph just crosses the x-axis. But 1 is a 0 with multiplicity 2, so the graph's got to turn around at that x-intercept. And it actually goes up to the y-intercept at that point. Now, from here, what occurs in between -3 and 2? We could just connect those up. That's a pretty good guess. I'd have to plot more points to verify. Actually, the graph rises up a little bit higher before it comes down. So we haven't verified that, but I just want you to see this graph. We do know a lot about the graph, but we'd either have to plot more points or check Desmos to see this little hump here. This turnaround point, we don't have any easy way of finding. So there's that 3rd degree polynomial graph. Again, just extra. We didn't have to do graph as part of the problem. The graph is just extra.